be looking at domain and range. So you may have heard these terms before, and we're going to relate it to function notation and just graphs in general. But we'll get to kind of the definitions, exactly what it means as well, of course, too. Okay, so first of all, just recapping what we've done so far in the first couple of lessons. We've looked at a function, and we've said that for a function, each x goes to only one y. As in, if you have some sort of input, you have a single output. And we saw how that worked with function notation. We said, given a function, you have x, it's going to spit out some sort of y. And you could replace that x with a number, and maybe it equals something like 4. Who knows? Depends on the actual function. But we had that. Another way I like to think of functions is a vending machine. Because what do we do at a vending machine? Well, in a vending machine, if you want to buy something, you have to, pay for the item. But the key thing is you have to input a code which will tell the machine what you want. So if you input A1, that's telling the machine you want that popcorn in the top left. And guess what? The machine will output the popcorn. So you have some input, which is the code, and the output, which is the item you want. So a vending machine is actually just a function. It's a very physical function, but it is, in a sense, just a function. And another way we can actually look at functions, sometimes we use this thing called mapping notation, which we'll see throughout the course. And what it really gets at, this mapping notation, is given some input is what we start with, is we tell it, what is the output? We map to the output. So it's just another way of thinking of kind of the function notation we were working with yesterday. So still very much the same sort of idea, just a new way of looking at it. So we could say we have some input going to some output, an x value going to this y value, or we could say mapping to the y value. B3, well, let's take a look at what B3 is. Well, B3 is there in the vending machine, and it looks like it's cereal. So B3 maps to cereal, or the input of B3 gives the output of cereal. And we could do something else. We could say C1, which is juice, goes to, as I just said, it goes to juice. So it maps to juice. And there you could do the whole mapping notation, which would mean listing all the different inputs with their corresponding outputs. And sometimes you may have seen these diagrams. These are mapping diagrams, which again tell you your input and give some sort of output, whether it's in terms of numbers or variables. And these are handy in situations where maybe you don't have a direct equation, but a situation like that vending machine. You have still inputs, you still have outputs, but it's not like you have an equation for the vending machine. Okay, now let's take a look at some further questions with this vending machine. So what would happen if you inputted A4? Well, take a look at your machine. Your machine is A1, A2, A3. There's no A4 there. You can't really input A4. Nothing's going to happen. There's no A4. So we need to keep that in mind. We need to know what we can actually input into this machine. What would I need to input to get water? Well, then you just need to look at where is water. Water is down in the bottom there, C3. So there is a number that would get you the water. What would I need to input to get some chips? We'll take a look. And if you take a look across the entire vending machine, there are no chips actually. It's not part of the vending machine. There is no output that is chips. And these two concepts, the first and the last question here, the fact that there's no A4, the fact that there are no chips, is going to lead us directly into what we think of as domain and range. Before we get to that though, let's just think of these as inputs and outputs. So all the inputs are just all the things you can type in. You can type in A1, A2, A3, and then you can do all the B's, B1, B2, B3. And what I'm going to do as I'm inputting these things, you can see I'm just listing it with comments. If we want to, in a sense, do this more formally, we can do these kind of curly brackets at the end of our list. So at the start and at the end, I'm going to have to go down a line. If you have enough space, do it all the way across. And then I'm going to put a curly bracket. The curly bracket just indicates that I have some sort of set. The set of A1 all the way to C4 there is the set of inputs. The set of outputs is, well, all the things that I can actually get. So the popcorn, and yeah, we'll write this all out. Nuts, pretzels, protein bar, the granola bar, cereal, energy bar, the orange juice. Oh, let's spell orange correct. And here's where we need to be careful. So there are 2 orange juices here. We have already listed orange juice here. You do not need to repeat listing it. You only need to list it once. Because we're just saying, what are the possible outputs? Well, I know I can get orange juice. I don't need to say that twice. And then you also have water. And it looks like some milk. And I'll just close that off with another curly bracket. Okay. So there we have all the possible inputs, all the possible outputs. In a sense, I have fully described what's happening with this vending machine. Okay, we're going to skip that activity because this is the video. But what we had there, those inputs, those outputs, are exactly what the domain and the range are getting at. The domain is just the set of input values. Or if we're thinking about like a function like f of x, it's everything that x could possibly be. And that's not necessarily always going to be any number. There are going to be situations, and we're going to see that, where we're going to have to look at only some numbers. And then the range, well, the range is just going to tell you what are all the possible outputs. So we saw the vending machine, you could get cereal, milk, water, orange juice, but you couldn't get chips. So chips were not part of the range, but those other things were. So the range is all the possible outputs. And so now what we want to do is we want to get used to how do we actually write that out in kind of a mathematically sound way that will apply to functions. And it's not going to be too important, all these things, but what we're going to make use of is just what we call number sets. So the real number sets, basically all the numbers that we make use of. Typically, there are other number sets, but the real numbers are all the things that you know. So things like 1, 2, 3, 4, fractions, integers, square roots, and special numbers like pi, which we use like an area of a circle, like pi r squared. So all of those are what we call real numbers, and these are just kind of specific subsets of that. So the natural numbers are just your counting numbers, 1, 2, 3, 4. Integers include the negatives and 0. And what we're going to see is we're typically going to really just make use of real numbers, but there are situations where you could make use of the other ones. But yeah, let's get into the notation. So for the notation, what we are going to do is we're going to indicate our input, or in this case, we're going to look at what possible x values we can have on the graph, which is going to be, if our graph is covering, if we're looking at it from left to right, because we're looking at x values, which is horizontal, because it's the horizontal axis, we're looking at basically numbers -2 all the way to 3, or actually 4, I should say. And just remember, if it's open means not included. And if it's filled in, it means included. So it is part of the function, whereas, so the number 4 is part of the function, whereas the number -2 is not. And so what we're going to do is to indicate all of this. First of all, what we're going to do is we're going to indicate the number set we're in. That will always be this x, This looks like an E, it's an epsilon, it's a Greek letter. Just like that. And it's just going to say x is an element, or is part of, and this is the real numbers. And I'll just say element of, or part of, or this. And so what we're saying is x could be a real number, and then what we have to do is we have to give it conditions, because it's not any number. It's not anything, but it's a number between -2 to 4. And so this vertical line that I draw, that's the condition. So I'm saying such that x can be anything from -2 to 4. So I'm going to start with -2. And I'm going to do just a regular less than sign, because we're not actually including the number 2. So -2 is less than x, or x is greater than -2. But we only go up to 4. And we are including 4, so I'm going to do a less than with an equal sign. Less than or equal to 4. And so there we have it. That is how we can indicate these x values on the right. So -2 to 4. And yeah, below is the translation just directly. So the set of real numbers, that's that first part, such that, that's the vertical line. And then the -2, less than x, less than or equal to 4. All right, let's continue. And this is just kind of recapping. So typically what we did there is set builder notation. We use a variable, x or y, depending on if we're looking at domain or range. The number type, usually we'll use R, and you'll see I usually do the double vertical. It's just the fancy way of stating real numbers. And then stating specifically what values are possible within there. So let's take a look at some situations. So we have here a parabola, and we need to keep in mind, well, what is a parabola like? Well, a parabola keeps going to the left, a parabola keeps going to the right. That's what those arrows are for. Graph keeps going. And so if we're looking at our domain, which is all the possible x values, well, almost always, you can always just start with this statement. X is an element of the real numbers. Since it's a line or a curve, it's covering every single possible number. We just need to see, is there a start or an end point? And in this case, well, there is no start. I could keep going to the left forever and ever. You could keep going further and further negative. Your graph would keep going. Same thing with to the right. Your graph would keep going to the right. There is no stopping point to your graph. So all I have to do is x is an element of the real numbers, and that's it. You can cover all numbers. And the range is all the possible y values. So for the range, you're looking vertically. So you can think of, where do I start vertically, where do I end, going from the bottom up, let's say. And if we're looking vertically, well, we can see we have a minimum of -3. And so then that means we would be any value bigger than -3, because we have no biggest value, because it's parabola, it just keeps going up and up. So to say bigger than or equal to -3, I can just use my less than greater than sign like that. This means y is greater than or equal to -3. And you'll see pretty much in all cases, the start will always be the same. Something is an element of the real numbers, and then we state the restrictions if there are some sort of restrictions. And by restrictions, I just mean numbers that can or can't happen. Like here, every number or y value has to be greater than or equal to -3. Okay, and let's take a look at this one. So we're going to do the domain first, and then we're going to do the range. Okay, so I'll start just as I did the other ones. X is some real number, and then we need to look at our graph. So going from left to right, we can see we kind of have two pieces in this graph, and we'll just look at both of these pieces kind of separately and just combine them together afterwards. So from this first piece, again, we're looking at just x values. We're starting at -4 and going all the way to here, kind of the middle, which is just 0. So the first piece is just -4 less than, we're not going to have the equal sign because it's open, x less than 0. But we have multiple pieces. We still have this piece to the right. This is all one function. It's all one graph. So it's not like you need to create a separate kind of domain set. You can keep it all within the same set. If you have more pieces, though, more conditions, you can just list it. And I'm going to list it using a comma. So the next condition is, well, we're going from 1 to 3. So if we're going from 1 to 3, I'm going to do 1. It's filled in, so I'm going to do 1 is less than or equal to x. And we're going all the way up to 3, so less than 3. And so that is the second piece, but all of that goes together as a single domain. So what that is telling us is we could be any x value between -4 to 0, which is that first piece, or from 1 to 3. And that covers all the possible x values that are covered in the graph. And the range is going to tell us what possible y values are covered. So in the same way, you can kind of think of the pieces and what is covered in those pieces. And if we take a look, I'll start with the red piece. It's lower. I always like to go from least to greatest. And that first piece, we cover from -2 to -1. So we're going from -2. It's not filled in. Just be careful. You're looking now vertically, so you're looking at the y values. So that's not included. But when we get to 1, the filled in dot is included, or I should say -1. So less than or equals -1. And then moving upwards, we have that first piece there, which goes from a height of 0, that's the y value, all the way to 4. And this is open, not filled in, so it doesn't include the endpoints. All right, and there we have it. That is the range. So it has two different pieces because, well, we have two different pieces there. All right, and let's continue. So just this last one, we want to sketch a graph of y equal to x plus 2, but then we want to restrict it to the domain. So sometimes we might have a function that could theoretically go on forever and ever, but depending on the actual situation, it might not make sense for it to continue forever. So sometimes we can restrict the domain. So, well, how do we draw y equals x plus 2? It's just a line. Slope is 1. And y-intercept is 2. So if that's the case, we can draw our y-intercept there. Slope of 1 just means across and up by 1. So like that. And I'll draw that like that. So that's just a portion of the line. But now what we want to do is we want to draw it from -3 to 1. So you could theoretically just draw it for the entirety. So that would be the whole line. And then just cut off the portions so that you're cutting it off from -3 to 1. So actually, I'm just going to cut it off right there at -3. Again, we're looking at x values. And then 1, well, 1 is what we have right here. So I'm just going to cut it off there. And then let's just pay careful attention to the signs. The first one is less than or equal to. So on the graph, we want a filled in dot there. That indicates that we reach that value of -3. Whereas on the right-hand side, x is getting up to 1, but we don't actually reach the value of 1. So we're going to do a open dot there, which means we get close to 1. We get up to like 0.99, and then the graph stops before it actually gets to 1. And so there we've now drawn the graph of y equal to x plus 2, but on that specified domain. All right, and that's a look at domain and range based on graphs.